Here's what I would do. First of all, I will simplify by 3. So then I have the square root of 6, the square root of x to the 4th, the square root of y to the 6th, divided by the square root of z. But these two will be radical free. How much? A y to the, good, the square root of 6 divided by the square root of z. So the only thing that needs to be rationalized from the numerator is square root of 6 and the square root of 6. That's it. So 6x squared y cubed over the square root of 6z. And we rationalize the numerator. Any questions? Any questions? The 18 and 3?
Yeah.
Of course. Yes. Absolutely, because otherwise it will be more difficult. Yes. Ready? Now, this is one type of rationalizing. There is a second type. And let's work on the second type. Any questions on the previous problem? Any questions? Okay, I claim that this is very different type of rationalizing, very different than what we've just looked at. Would you agree? Or can you explain why I say that? I claim that this problem is totally different than all problems we looked at with rationalizing. Would you agree? Why? Okay. I'm sorry?
Why'd you do that?
Because
Are you gonna make it more difficult?
no, because Savannah said, she said, oh, it's different because there are no variables.
Oh.
And exactly. So I made it more complicated. Yes, the denominator, that's exactly why. That's the reason. The denominator has 2 terms now. So this is way more difficult. I shouldn't say way, but it's more difficult because it doesn't have just one term, one product to deal with, but it has 2 terms. And this is one of our contracts from a long time ago. A plus B will be multiplied by what to get a squared minus b squared? What do we multiply a plus b by to get a squared minus b squared? We only have 3 different things in our contract. Say it again. Wonderful. The conjugate. These are called conjugates. So we need the conjugate of the expression we have in the denominator. Can anyone identify the conjugate for us now? Because I have to put it top and bottom because in the end, the value of that fraction has to be 1. Very good. The top is nice because I multiply by 1 and I'm done. But now, let's use the contract and get the denominator. I have to square the first term. There are 2 factors in there. Please square the first term, the first factor. Please square the first factor. Y squared. And now square the second factor. 2. So what should I write? Okay, very good. Yes, I agree with 2y squared. Remember, you have to write minus. Let's square the second term. What do I get? What do I get? Very good. So we rationalized the denominator, but we did not use the same procedure as before. Why? Because the denominator was way more complicated. It had 2 terms instead of 1. And now let's choose 47. And that's the square root of a plus 1. Everything divided by 2, the square root of a minus the square root of b. Please tell us what we need to multiply and divide by. Very good. Plus? Yes, square root of b. So 2 the square root of a plus the square root of b. The denominator requires us to put minus in between the 2 terms, square the first term, and square the second term. When you square the first term, what do you get? Please square the first term. I agree. Please square the second term. B. But now you have to FOIL the numerator. So tell me what should I write when you're ready. We have to distribute the square root of a to these 2, and then 1 to these 2. So I need 4 terms. We multiply the outside. 1 times 2, and then radicals. The square root of a times the square root of a. Very good. Remember, if we were told that a can be any real number, then we would have used the absolute value. We assume everything is positive, so it's 2a. Now I multiply the square root of a by the square root of b. So then plus square root of ab. Excellent. Plus, very good, plus, that's it. Are there like radicals at the top? No. Very good. This is it. Okay, one more. 52. And I'll let you work on 52. 2 the square root of a divided by 2 the square root of x minus the square root of y. 1 minute. Can anyone tell us what to multiply and divide by? Very good. Indeed, to the square root of x plus the square root of y. Perfect. Can anyone give us the numerator? Oh, was it a in there? Yeah, there was. Yeah. I thought I maybe copied something else. Can anyone give us a denominator? Because the denominator is easier. So 4? Yes? Excellent. Do you all agree with 4x minus y? Perfect. Now please distribute. 4. The square root of ax, I agree, plus. That's it. And no one can simplify this any further. Okay, let's rationalize one numerator. Let's say problem 80. The square root of 8, which has to be simplified, minus the square root of 3 over the square root of 2 plus the square root of 3. We rationalize the numerator now. Simplify the square root of 8 and then find the quantity we need to use to rationalize the numerator this time. That happens, not frequently, but it happens. When you have the simplified form of the square root of 8, I like to put it in first. How will you split the square root of 8? Into what and what? So the answer is don't try to simplify anything. These are terms. You cannot simplify. So tell me what you need to multiply and divide by to rationalize the numerator this time. Very good. Indeed. The numerator is easy. The denominator needs some time. Can anyone give us the numerator? The first term squared. Say it again. Times 4 times 2, which is? Very good. Minus the second term squared. Now the denominator. You must distribute the square root of 2 to these two terms, and then the square root of 3 to these two terms. So initially, you'll give me 4 terms. Ready? Yes, because it's 2 times the square root of 2 times the square root of 2 is 4. I agree. So plus the square root of 6. Plus. Very good. Very good. Yes, I will combine like terms at the top, and I will combine like terms in the denominator. When I combine like terms at the top, I get. When I combine like terms in the denominator, I get plus. Yes, that's it. We rationalize the numerator. Now, the next section, this is again my opinion, and it's not true for all, I think is one of the 2 topics that are difficult in this course. So I would like you to pay attention, please, to make it easy. So this is section 10.6, solving radical equations. allow me to explain the concept first on a simple example, very simple example, that is not even a radical equation. But I need to explain the concept. I need to show you or tell you what we're trying to do. So let's suppose I have the equation x equals 2. Is this an equation? Yes. Left-hand side, equal symbol, right-hand side. And let's suppose I want to square both sides. And rightfully so, you would ask, why? And I will say, for no reason. Just bear with me to explain the method. Of course, I will never square both sides of such an equation. There is no need. But I'm explaining the method with a very simple example. Okay, how many solutions does this equation have? One, right? It's x equals 2, right? One solution. Now, I decide, for an odd reason, actually no reason, to square both sides. Can you square the left-hand side for me? Good. Can you square the right-hand side for me? 4. And let's move forward to the other side, and I have x squared minus 4. Let's factor the left-hand side. Those will be 3 terms. X plus 2 squared will be 3 terms. I cannot write x plus 2 times x plus 2 because it will be 3 terms. We have a contract. X plus 2 squared is 3 terms. Or x minus 2. So there are 2 options here. X is and x is. Or, right. So here's the dilemma. I started with an equation with how many solutions? I squared both sides and I got an equation with 2 solutions. But definitely one of these 2 does not verify the original equation. So when I plug in 2, I get 2 equals 2. Is that correct? But if I want to plug in negative 2, will that be correct? So this solution is called extraneous solution. It's not solution of the original problem. So here's the question. If I add 5 to both sides of an equation, will I change the solution? No. If I subtract 10 from both sides of an equation, will I change the solution? No. If I multiply both sides by 5, will I change the solution? No. When I divide both sides by 10, will I change the solution? No. But look what happens now. When I use this principle of squaring both sides or raising both sides to another power, to a power, I may end up having solutions that do not work in the original problem. Here's an example. Although you could say, but you will never do this to a linear equation. That's true. But I will have to apply this method to solve radical equations. So how will I go about solving this problem of not getting a solution or not accepting a solution that is not a solution of the original problem? What do you think will be part of the problem? What do you think I will have to do no matter what? Exactly what we just did. How did I identify the fact that x equals negative 2 was not the solution? Exactly. Now that's a big note. When raising both sides of an equation to a power, comma, one more time, when raising both sides of an equation to a power, when raising both sides of an equation to a power, we must check all potential solutions where back in the original equation. When raising both sides of an equation to a power, we must check all potential solutions back in the original equation. And now we're ready to look at problem 7 on page 630, where we are given the equation the square root of 4x minus 3 minus 5 equals 0. What do you think will be the very first step that I have to perform before I even think? Very good. I have to separate the radical from the rest. Isolate the radical from the rest. I'm adding 5 to both sides. Now, the principle of powers indicates that I have no way of removing the radical unless I do something to both sides. What? Why not cube? Don't write this. I decide to cube. I don't want to square.
You have to square it to get rid of the radical.
Of the square root. Absolutely. So 3 will not work. What power is the square root?
2.
No, it's not 2. What power is the square root? We did that last week. What power is the square root? What power is the cube root? 1 over 3.
So that's 1 over 2.
Right. So since this is power 1 over 2, that's the reason why I square both sides. Copy the base, multiply the exponents. 1 over 2 times 2 will be 1. So what do I have on the left?
4x minus 3.
Very good. Already know that. What do I have on the right? Very good. Now this becomes a linear equation. How do I solve a linear equation? Yes. So 4x equals? Good. Finally, x equals? But it comes with a big question mark. Why?
You have to check.
Right. That's the note we just wrote. Every time I raise both sides to a power, 2, 3, 4, 5, I have to check the solution or the potential solution. It's not a solution just yet. Back to the original problem. How much is 4 times 7? How much? How much is 28 minus 3? How much is the square root of 25? How much is 5 minus 5? That's it. Only now I say, yes, I checked. It works. Could I get 2 solutions that work? Yes. Could I get 2 solutions and none of them works? Yes. Could I get 2 solutions and one works and one doesn't? Yes. So you have to be very careful. This is part of the problem, of the solution, I should say. Okay. Now, let's look at, 29. 29, the fourth root of 4x plus 1 minus 2 equals 0. What do I do with this? Not yet. I need to isolate the radical first. So what should I do? Good. Now, squaring both sides, will that work? No, because squaring 1/4, it's not going to work. But I will have to do what? That's it. So what is the left-hand side equal to? What does it equal to? What does the right-hand side equal to? So then 4x must equal, I subtract 1. When I move a positive term from one side to the other, it becomes negative. So this is 15. So x appears to be 15/4. I'm not sure. I don't know. Maybe, but I have to check. So I'll go back here. So I have 4 times 15/4 plus 1 with the 4th root on top. So I'll simplify 4 and 4. What is left from this product? When I simplify 4 and 4, what is left from this product? 15 plus 1 is? The 4th root of 16 is? 2 minus 2 is? I'll say yes, because I checked. Of course, there are more complicated situations. And here's one. 15. The square root of 13 minus x equals x minus 1. Before we address this, we have to write a note. Never square term by term. Never square term by term. Let me give an example of what I mean. Is 2 plus 3 5? Would you agree? Is that correct? Good. You cannot do this. This will be a terrible mistake. Terrible mistake. No. This is 4. This is 9. It will never equal 25. So please don't ever do that. What you can do is square the left-hand side as 1 unit together and square the right-hand side as 1 unit, not term by term. So therefore, when you square the left-hand side, what do you get? Can anyone tell us? The left-hand side. Very good. But you have to be very careful with the right-hand side because we have a contract on that. How many terms will you give me for the right-hand side? Very good. Remember the tune. First term squared minus 2 times the first times the second plus the second term squared. Ready. Very good. Plus. The last term is always 1. Plus. Good. Now what type of equation is this? Because the previous one was a linear equation, no problem. We separated and we divided. It was done in a blink. But what type of equation is this? And what do I do with it? If it's not linear, what else? What other types of equations we know? Very good. Excellent. It's a quadratic equation. How do I solve a quadratic equation? Very good. So I'll move this, and I'll move this, and I'll have 0 on the left or on the right. It doesn't matter. X squared. The middle term, please. Sine. Perfect. And now the free term. Very good. Excellent. Now I need to factor. What do I get? Very good. So two options here. And they are? Yes? -3 and 4. Excellent. But look at this. What am I really saying here?
They can't be both at the same time.
Yes, they can, but not at the same time. Of course, you cannot give two values to x at the same time, but you can have two solutions. So on the left-hand side, you cannot put x equals 4, and on the other side, x equals -3. So what do I need to do? Why do I have those question marks in there? Yes, I'm going to write the original problem here. 13 minus x equals x minus 1. I am plugging in all the way -3. So how much is 13 minus -3? 16. How much is the square root of 16 on the left-hand side? 4. What do I have on the right-hand side? How much? Good. So is this acceptable?
No.
No. So therefore, this is not a solution. This is what we call the extraneous solution. Now I'm checking 4. 4 here and 4 here. 13 minus 4. The square root of 9. The right-hand side. Will you accept x equals 4? Of course, 3 equals 3. That is the solution, yes. But x equals -3 is not. Any questions? Last problem, I'll choose one and you work on it. Problem 39. X minus the square root of y minus x equals -5. In comparison to the previous one, you have here an additional step. This one, the radical was already isolated. This one does not have the radical isolated. So what I would recommend, because there is minus here and minus here, this is what I would do. I would do this. Add 5 to both sides and move the radical to the other side so everything has positive sign. But it's up to you. But you cannot square as is. You must isolate the radical first. So can anyone dictate the starting point so I can write it for everyone to see? X plus 5 equals? Very good. So now we isolated the radical. This is a must. We can't start without isolating the radical. And then, what will you do next after you isolate the radical? Yes. How many terms will you get on the left-hand side? Very good. Please do not forget that. I'm looking for my syllabus so we can put it in as the test 2 date. So I'm looking at my phone too, because I don't know what, today is the 13th, next week will be the 20th, right? So Tuesday would be, no, the 25th, following Tuesday,
Oh, yeah.
right? So let's put it in. Test 2, 1025, and it covers all this. entire chapter 10, and 3 sections from chapter 9. So please write it down, test 2, 1025. On Tuesday, we'll finish the last section, which will take a few minutes. We will practice more radical equations, and we'll start reviewing for the test. But the following Thursday, I have to move on because we have 2 more tests. Okay, can anyone tell me what to write for this so we can finish this problem? X squared, I agree. Plus 2 times the first times the second. Very good. Plus, very good. And the right hand side. That's it. Finally, what type of equation is this? And it's a quadratic equation, so I have to. Very good. So x squared I'm bringing a positive one. Plus 11x. If it's negative here, and when I move it to the other side, it will become positive. If it's positive here, when I move it to the other side, it will become negative.
It's 21.
Product 24, sum 11. Here's the original equation. I'm plugging in negative 8. One minus negative 8. So 1 minus negative 8 is 1 minus negative 8 is 1 plus 8, which is 9. Perfect. So the square root of 9 is good. So negative 8 minus 3, does this equal negative 5?
No.
No. I'm checking negative 3. 1 minus negative 3. 4. Let's go to 4. 2. Negative 3 minus 2. Does this equal negative 5? So another equation that has only one solution. Thank you for coming. I will see you on Tuesday. Don't forget your homework. Yes.
Plus 2.
Say it again.
Only plus this side plus.
No. Next Tuesday. Yes. Yes. I thought you said next class.
No.
No. Next Tuesday we'll finish this chapter and start reviewing and review, and then on Thursday we'll move on. And thank you. And then the test will be the following Tuesday. Thank you. Thank you. That's okay. I'll stay for it. Yes. Totally factored. Because the product is 24, they come to 24, and their sum is 11. Yeah, this is in chapter, thank you. Chapter 6. Thank you. Thank you. Thank you. Thank you, you too. Thank you. I always want homework. I don't have anything to do. I'm just kidding. But I have But I'm hoping you too. I'm hoping that homework helps too. That's why I'm doing it. Thank you.